I would like to show you a very useful tool for graphing surfaces in in R3 in 3D. And this tool is called Desmos. You can just go on Google and type it, or type it up in the search bar. This is Desmos. So it's Desmos. You know what? Let's go to Google. So I'll leave this. So this is Google. Let's go to Desmos. Desmos. I'll say Desmos 3D. There are two versions of Desmos, but this is Desmos 3D graphing. All right. So click on that. Okay. So this is where I was before. Okay. So let's try graphing a few surfaces. So you go on the left right side, left hand side. um, there are fields to fill in there. So assuming you want to sketch the surface or the plane 2x minus 3y, just making this up, plus 6z equals 12. So as you're typing, it's already graphing. It's already sketching it. So this is what we have. All right. Okay. So this is a plane, as we all know. How about we try, so this is the x-axis, z-axis, y-axis. How about we try a cylinder? Let's try the cylinder z. No, let's say z minus cosine y. All done. Hope this makes sense. How do I do cosine? So z minus cosine y equals 0. Okay, yes. So as we can see, this is a cylinder. It doesn't have the variable x, so the cylinder is parallel to the x-axis. Now, how about we want to add one more thing. Say we want to sketch both the cylinder and the plane in the same space. So we get another field. See here, we add another field, like click the plus sign, say expression. So we want to add the 2x, the plane that we had before, 3y, and then plus 6z is equal to 12. So we have both of them on the same space. It looks interesting, but it's a little useless. So you can rotate by just using your mouse and hovering around it, you know. Okay, now, so that is a cylinder. Now, how about we sketch maybe an elliptic paraboloid, one of my favorite surfaces. First of all, I need to get this to stop rotating. All right, I think that's it. Okay, so I have z is equal to maybe 4x squared, 4x squared plus y squared. So this is an elliptic paraboloid. So as you can see, yeah, elliptic paraboloid. Okay, let me keep going. Let me sketch a surface that we've looked at, that we found its critical points and we classified them, and we classify them as maximum, minimum, and saddle points. So that surface was z equals x squared minus 2x times y squared plus 3y. So that's what we have. And why is it this color? Hold on, can I change the color? Oh no, I cannot. Well, I feel like there are ways to change the color, so that will be something you should be able to figure out. So you see how very funky and interesting this surface is. I think we got a bunch of fixed points, a bunch of critical points. I think the first one we got was 0, 0. So let's add a point. So you can just add a point, like when you click on expression, just add the point. So the point was, the critical point was 0, 0. So 0, 0, 0. We have a bunch of critical points. We had 5 critical points. Okay. So we had 0, 0, but 0, 0, if you plug in 0, 0, 0 for x and 0 for y, you also get 0 here. So let's make it 0, 0, 0. Okay. So you see that's a critical point. And if you remember from the other lectures when we did maximum and minimum value, 0, 0 was a critical point, and 0, 0 gave us, we classified it as a saddle point. Now, let's try another point. We also had 2, 0. So if we do 2, 0, 2, 0 will give us 2, 0, 2, 0, 0. Yes. So we see that is also a saddle point. All right. So how about let's do 2, 2, -3/2. So if we plug 2 and plug 2 for x and -3/2 for y. Actually, 1, we also have, 1 and -3/2. So let me plug it in there. So if I plug 1 minus 2 times 1 squared minus 2 times 1, and then -3/2. I should have done this before coming on live, but it's fine. -3/2 for y. So we had, you know what? Okay, so let me see. Let's do 1 squared. Okay, 1 squared. And then minus 2 times 1. Look at me solving math. Okay. Times, and then -3/2 squared plus 3 times -3/2. Hopefully this works. This is 2.25. Okay. So let's go back. That should be 2.25. So let's add the point 1, -3/2, and then 2.25. I hope this makes sense. Okay. So that's the point we see, and that's a relative max. All right. So this is a relative maximum. Okay, there are other fixed points, other critical points, but I'm not going to worry about doing them. This point and this point. If you go back to the lecture, maximum and minimum, you figure out the remaining two critical points, and then you'll be able to plot them. Okay, so that's it. That's all I want to show you. Desmos 3D, desmos.com/3D. All right, later.